Hello, this is Mr. Wynn, and this video is about angles, part 1, where we're going to be naming, classifying, and identifying the relationships. So a ray is a part of a line. It has one endpoint or start point and extends indefinitely or infinitely in one direction only. When naming a ray, use two capital letters and then draw a ray on top of the letters. One of the letters will have an arrow. So here's an example, ray. You can call it ray AR, or you just use AR with the rays on top. Make sure the arrow's on R, not A, because it starts on A and goes to R. Alright, this is not the same thing as ray R to A, because that would be starting at R and going towards A and keep going past A. Alright, opposite rays are two rays that share a common endpoint and go opposite directions. Together they always form a line. So here, ray starting at A going to H, so this left ray, and ray AT, so starting at A going to T, that right ray are opposite rays, and together they form line L. So an angle is formed by two rays with a common endpoint. So here's a picture of an angle. The common endpoint is called the vertex of the angle. So here's the common endpoint. So these two rays share the starting point x, because it goes x to y, x to z. Alright, then the rays themselves are called sides of the angle. So this angle has two sides, this bottom side, this top side. When naming angles, you should use three capital letters, where the vertex must be the second of the three letters. You can also name an angle by a single letter sometimes, but only when there's exactly one angle located at the vertex. Also, if there's a number located at the angle, you can use that number to name it as well. And whatever method you choose, be sure to include the angle symbol in front. So this above angle can be named as angle YXZ. So starting at Y, going to X, going to Z. So here's me tracing it. That is the same angle. You can reverse the letter order, but X must be in the middle. So you can call it angle ZXY. So starting at Z, going to X, going to Y. Same angle, basic angle X. Or because there's only one angle there, we can call this X because there's nothing else to confuse us. Or there's 3 here, you can call it angle 3. Now here's another example where you can't use a single letter. So notice in this angle picture to the right, you cannot just say angle B, because I don't know what you're talking about. It could be the top angle, which is angle ABC, or you can reverse that to CBA, that's the top angle. Or the bottom angle, for example CBD or DBC, or the entire whole big angle, the whole thing, angle ABD or DBA. So I don't know what angle B is, so you cannot use a single letter here. So to be safe, you should always use 3 letters. Alright, when you have an angle in a plane, the angle divides the plane into 3 distinct parts. There's on the angle, inside the angle, and outside the angle. So in this picture right here, notice that Q, M, and N are actually on the angle itself, lie on the angle. Then S and R in this dark shade area is inside the angle. We call that the interior of the angle. And then P and O are in this outside part. We call it the exterior of the angle. Alright, angles can be classified depending on the measure. Hopefully I know the word acute. Acute angles are those that measure less than 90 degrees. So here's an example picture. This is 38 degrees. Next we have right angles. Right angles measure exactly 90. So here's a right angle. It could have 90 degrees, or it could have a box, either one. They don't have to have both. So you might see the right angle box instead of the 90 degrees, or maybe you'll see the 90 degree number, but no box. Then we have obtuse angles. Those are angles that measure greater than 90 degrees. Here's an example. 133 is bigger than 90. And last we have straight. Straight angles measure exactly 180. Alright, so I kind of do this angle mark 180 degrees. Notice that lines always make 100 degrees because lines are by definition straight. Angles can also be congruent, meaning they have equal measures. So here's angle A and angle B. I can say if angle A is congruent to angle B, then the measure of angle A is equal to the measure of angle B. Alright, so make sure you know when referencing an angle, just name the angle, angle A. When referencing the numerical value or degree measure of an angle, put the letter M before the angle symbol because M stands for measure. So in that picture above, angle A is the entire picture right here. Alright, but measure of angle A is the number 42. Also, sometimes pictures have matching angle marks. So similar to the tick or hash marks, meaning congruent segments or sides, these mean those angles are congruent, so they have equal measures. So here I have 2 angles. I have this one green mark, angle mark. Since they're both 1 each, that means measure angle C is equal to measure angle D. And here I have 3 purple marks, 3 purple marks. So it's the same number of markings. We know the measure of angle F is the same as measure angle B. Alright, there are 5 angle relationships you need to be able to identify and describe when dealing with pair angles. The first one is adjacent angles. Adjacent angles are two angles that share a common vertex, so start point, and common side, but different interiors. So here's angle 7 is on top, and here's angle 8 on bottom. These two are adjacent because they share the same blue side in the middle. For here, we see angle 1 and 2 are adjacent because they share the middle side, the blue one. Angle 2 and 3 are also adjacent because they share that purple side. But if you go to 1 and 3, they are not adjacent because they don't have anything in common, no shared side. Then here, we have angle CLA. CLA is the top angle. Angle PLA, the bottom angle, are adjacent because they share side LA. But if you do CLA, this top angle, and then CLP, the entire thing, those are not adjacent. Even though they have the same CL side, CLP has the same interior as CLA. Alright, also remember, you cannot trust pictures. They're not drawn to scale. You cannot assume that angle CLP is a right angle. You have to see 90 degrees with a little box right here. Alright, next we have complementary angles. Complementary angles are two angles whose measures add up to 90 degrees. The two angles do not have to be touching or adjacent, and a big hint is the right angle box. So like in this first picture, angle 4 and 5, they are complementary because together they make 90 degrees. These two make this right angle box right here. See that 90? So these are adjacent, they're touching. Here, these are non-adjacent, non-touching angles, but these are also complementary because if you do 40 plus 50, you get 90. After complementary comes supplementary. So same idea, except angles, two angles add up to 180. Again, they don't have to be touching, but they can. And the big hint is seeing a straight line, because a straight line means 180 degrees. So here, angle 1 and 2, this does make a straight line. I could mark it like this. So that is 180. Half circles are 180 as well. Alright, no, it's a straight line. Then here, they're not touching, but 120 degrees and 60 degrees add together, you get 180. So angle TOP and angle SAY are supplementary because they add up to 180. Next one is linear pairs. Linear pairs are two angles that are adjacent and form a straight line. Two conditions. Now by default, they are supplementary because they are a straight line, and lines are always 180. So here, notice angle 9 and 10 makes a straight line right here. It doesn't bend or anything. I could draw that. They are a linear pair because they are adjacent. They have the same middle side right here, and they form this straight line together. Over here, none of those angles form linear pairs because they don't form a single straight line. These four little line pieces are different because they have different slopes. Remember, straight lines do not bend. The closest one would be, I guess, this, but it bends right here. Alright, then we have vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. They are sometimes called bow tie or kissing angles, and they are always congruent to each other, meaning their measures are equal. So these are the same picture, I just had some coloring here. But notice, 35 degrees, 35 degrees. They're the same. 145 degrees, 145 degrees. They're the same. So angle 1 and 3 are vertical, and then 2 and 4 are also vertical. So there's two pairs of vertical angles here. Now the reason why they're called bow tie angles is if I had to color it, see 1 and 3 make this, these are both green, they kind of make a bow tie picture. Or you can think of two faces kissing each other. Same for the yellow. Alright, now over here there's a lot. So AGF is this top left angle, and DGC is the bottom right angle. They are vertical. They're directly across from each other, kissing, same size. AGC is this top right. Ignore that B part. And then FGD is the bottom left. They are also adjacent. Vertical. Now there are a lot of non-vertical angle pairs. Let me tell you why first. Remember, they must be directly across from each other and form a perfect X. Again, it's two lines without bending. So let's look at AGB first. AGB is this top right angle, and then it goes to EGD. EGG is down here. Now they're almost across, but you see how this line bends right here? That's not a straight line, so those are not vertical. Alright, EGD is the same one right here, and BGC is over here. These are definitely not verticals. This is not a straight line. None of them even connect straight. Then FGE is this one right here. And then BGC are not the same because this is not a straight line, it bends. Alright, last slide. Use the picture above to classify each angle pair as adjacent So we'll abbreviate A, vertical for V, linear pair is LP, complementary C, supplementary S, or N, none. All right, RTL. So RTL, R to T to L is this top part piece right here. Then L to T to N. So starting at L to T to N, it's this piece. These two are adjacent. They're side by side. They share LT. Now I don't know their measure, so I can't say it's supplementary or anything else. So it's just adjacent. All right, next one. RTL. So same top angle right here. And LTN. L to T. Sorry. RTL, STE. STE. S to TE is this right here. Notice these make bow tie angles. So this makes a perfect cross right here. It goes straight line, straight line. So these are kissing. They're both 110. So I'm going to call them vertical. All right, next one. RTL, RTS. RTL is the same right here. RTS. Starting R, going to T, going to S is this piece right here. Notice these two together are adjacent. They have RT together. Also, they make the straight line, SL. So they're adjacent and straight. So adjacent, linear pair, because make a line, and then linear pair straight is supplementary. All right, next one. RTL, same up here. And we're going to NTE. NTE is this. They're not adjacent. They have this big gap right here. They're not linear pair. They're not vertical. They're nothing. So none. All right, next we have RTL and LTE. L to T to E. So L to T is all this. Notice these are adjacent. They share LT. Also, they make a straight line. So that's a linear pair. And all linear pairs are always supplementary. So A, L, P, S. And the last question, RTS, that's a different angle. RTS is right here. And then LTE. LTE is this. Notice these two are diagonally across from each other, and they make this perfect X right here, straight. So because they're across, I could color this if I wanted to. These are bow tie angles. These are vertical angles. And that's it. Hope you enjoyed the video. Make sure you ask some questions. Thanks for watching. See you soon. Bye.